Instead of having the operator select the best response, they simply look at the responses the machine is giving and intervene if something looks crazy. Now the problem is that's expensive, right? You have to have a lot of humans.
Today's conversation is with Charles Martin. Charles is the founder of Weight Watcher, which is an open source tool for analyzing your own deep neural network. Charles holds his own Ph.D. From the University of Chicago, and he is considered one of the major voices when it comes to the LLM evaluation. I also should mention that he has an extensive experience when it comes to natural language processing, helping variety of companies adding and adapting their AI product base to their own pipeline. Companies include, but not limited to, eBay, Walmart, Google, Demand Media, and many more. So, Charles, thank you so much for being here.
Hey, thanks for having me. Glad to be here.
Absolutely. So I really wanted to start reflecting on the LLM evaluation part on the 2023 years specifically, and looking back into the increasing demand for these type of tools and approaches. And I just wanted me to pick up your mind on what caused this rising phenomena of LLM evaluation and why it is one of the fastest growing subfield within the AI.
Well, I would explain it. Look, I've been doing text generation, machine learning for many, many years. Several years ago, prior to GPT, I had a client who wanted to make things like reviews on Amazon, right? Weight loss articles. We were using LSTMs to do this. And it became very clear to me, even back then, several years ago, that if you're going to generate 100,000 reviews for Amazon, how do you know if they're any good? Right? How do you prune them and make sure you're giving something of, when the user comes in, that they get something high quality versus something which is junk? And, at that scale, there's no way you can test them. So I began at that point looking at, I began looking at ways to evaluate the text. And so I think this problem has been around for a long time. It's just that now text generation is everywhere. Right? Everybody wants to use LLMs. And so they're finding out that while you can generate all sorts of amazing things with them, you can answer questions and generate copy. They have a lot of problems, and you need techniques to figure out how to run them at scale, because you can't expect to have a human evaluate everything. And I think that's why we're seeing this.
And what is the difference between the LLM evaluation and where we came from as a traditional evaluation of machine learning? What is the degree of complexity here?
Well, first of all, typically in machine learning, you look at classification, right? How well is, you have a classifier, or you're trying to make some prediction about something. And so you know the answer, or you have some idea of what the answer should be. So you can just test the out of sample performance, right? I have some SVM or XGBoost. I kind of have an idea what the out of sample performance should be. If I'm good at constructing a test set, I can evaluate the thing. When it comes to LLMs, the only thing people really have is the test loss. They train different models. They look at the test loss or the perplexity, which is related, and they think, well, that correlates with generalization. And that's all they have. And they have no idea what's going on under the hood, why these LLMs even work. So, of course, they make mistakes, they hallucinate, they generate things you don't want. So it makes it much, much harder to evaluate what you have. You either have the test loss, or you have something like some overlap metric between what you think you're training on and what you're not. And it's all basically the same thing. There's nothing under the hood which tells you what's wrong with the model. Is the text correct? Is it coherent? That kind of thing.
So in terms of methods and techniques and tools for LLM evaluation, specifically, I know for sure like benchmarking has been one of the main things that everybody is doing. It's either in a high level or like maybe a domain specific type of benchmarking. But beside that, I know that there is a human evaluation. So if you can just walk us through what is available and what people are actually doing up to the moment in terms of approach and methods and tools,
Well,
and feel free
it's a
to mention
mess.
any
I
of them.
mean, if you look at
It
what
is.
people are trying to make benchmarks for open source models, but the problem is nobody knows what's really in the data sets. So there was an interesting paper that came out a few days ago, at least I saw it a few days ago, that shows if you look at benchmarks that were developed after the models were produced, they actually do tremendously worse. So you think, oh, you're doing zero shot performance on an LLM. It turns out that there's a huge difference between looking at a benchmark that's produced after a model's released as opposed to prior to the model's released. And there's a huge problem just with data set corruption, right? The data sets are contaminated in training the models. So there are lots of, there are 100 different benchmarks, coding benchmarks, truthfulness benchmarks, hallucination benchmarks. The problem is you have to pick one. If you're looking in a very specific domain, you've got to be careful that the data set you're using hasn't been contaminated with the benchmark. And that's a huge problem that I see. And I think that's typical what we see even in companies, right? People try to deploy AI or ML models, and many cases I've worked with clients, and it turns out that the training data that you think is training data is actually contaminated with data you're trying to make predictions on. And so it's a mess. But I think that, most people are just going to Hugging Face, or there's some LLM evaluation tools. They're trying to do this. So I can go into more details if you like.
That would be perfect. That's what I'm looking for actually here, like because I think even though the benchmarking has its own benefits as probably the first stage of you to just gain some understanding of your foundational model. But let me go like a further deep here, and if we consider like the foundational model as the operating system, right?
Okay.
And now, me as a company who wanted to utilize this type of LLM, I'm just gonna build an application in the top of it. So how I can differentiate between the original benchmark that is designed maybe to benchmark the actual foundational model, and then the actual evaluation for my own domain specific, use case specific type of evaluation.
Well,
So how I can differentiate between them.
I think it's challenging depending on if you're building a classifier, if you're trying to like classify emails, right? I have an email classifier, and I want to take some foundational model and I want to bootstrap it so I can do zero shot performance classification. In the end, the kind of evaluations that you see, I mean, that's like a typical type of out of sample data set. You have to create a data set which you feel really represents what is your out of sample data. And it's very, very hard because you never know what is really out of sample data. And on the other hand, if you look at what people are using in terms of benchmark algorithms, they'll use something like maybe Rogue. There's some standout like Rogue, and they'll basically looking at, here are the words that you think that, but if you're not doing classification, say you're doing like you're generating text, they'll take some model like, here are the words that are being generated, and here are the words that should have been generated, and you try to count how many words overlap with the words that were generated. And the problem is there are all sorts of different ways of doing that. Do you count 2 words in a row, 3 words in a row? Can you have 2 words, but they can be separated by another word in between? There are probably half a dozen of these different metrics, all of which will give you slightly different results, or all sort of the same metric. The problem is they only work on on the sequence itself. One of the things I had to, so if you're doing like basic classification, you just have to create a data set, and that's where you are, or you find a gold standard on the internet, and it's always a problem. If you're doing text generation, which I think a lot of people want to use LLMs for text generation, one of the products I developed years ago was a coherency metric. So it would take the document collection you have, and you run something like latent semantic analysis, some old school clustering algorithm. And then you can use that to measure the semantic coherence of your sentences. And so in the old days, that's how you had to do it. You had to ask, this thing would just generate a bunch of sentences, and you would try to figure out whether the paragraphs it's generating are semantically coherent as you move down from one sentence to the next. I think today with most modern LLMs, that's not so problematic until you start getting into very, very long sequences. I think it's much more things like you're trying to generate a certain kind of response and you don't want it to be so wordy. Like the response is too wordy. You want to summarize something versus you want to have a direct you want it to be direct, or you want to have it give a list of bullet points, but it's just too long, or it's not doing in these are the kind of things that come up in interacting with customers. And a lot of it is still very ad hoc.
Yeah, and that's actually lead me to the main challenge I think every company having right now, which is defining those metrics. Previously in traditional ML, we used to have a predefined matrix. You have F1 score, you have like you mentioned rogue,
Confusion
you mentioned
matrix, yeah, right. Yeah.
confusion matrix and all of that. But now you have more of a use case, a specific type of matrix. You have a matrix that is actually tied to the KPI, what you need out of it in terms of business. You have another matrix that is actually related to the retrieval system. So is it retrieving the same exact segment that I wanted to retrieve? So
Yeah, for those kinds of systems, yes. No, the problem is that in any kind of retrieval system, right, you can usually get things that are very, very exact, lexical match, right? Or you can get something very abstract. Oh, I'm looking for a restaurant in San Francisco. Anything will do, right? But it's that mid-range where you're not so abstract and you're not so exact and you're trying to sort of figure out the intent of the user. It's very hard. It's very hard, especially now because these things tend to hallucinate. So they also make stuff up. So how do you know? You have to go and check the results. And I think that was always been a problem in search. And it's been like that for 20 years, that mid-range trying to figure out what is the user intent. And I don't think, the problem is you're trying to use evaluation metrics and you're trying to really figure out user intent. And user intent is much, much harder in an open domain system. Somebody just asked an arbitrary question. If it's a question that people ask all the time, then it's fairly easy because you can just sort of record the questions people ask and ask, oh, is this question similar to something somebody else asked? And if it was, is the answer similar to something you get? Is it similar to the most popular answer? But if it's not popularity based, then you have a real issue because you don't know what the intent is. And most of the systems I've worked in, it turns out that popularity based, this sort of, you're doing on broad spectrum search, either it's e-commerce or enterprise search internally, many times what happens is you just keep giving the same answer over and over and over. You have a question, you input the query, you find another query that's as similar to it as possible, using some cosine overlap or embedding or whatever. And then you find the answer that's the most popular for that query. And you end up just showing the most popular answers over and over and over. And eventually the system cannibalizes itself because you don't get into the long tail. But that's actually a very common solution that you would do that. And figuring out whether the answer is any good, unless you have explicit user feedback, it's quite hard.
that is absolutely a great point, and lead me to my second question actually. Because the nature of those LLMs is non-deterministic, you could ask the same exact question and every time you would have totally different answer.
Yeah.
And because of this nature, I think that's why a lot of companies, they are adapting the human in the loop. And I would really need to, or maybe want to understand your perspective on the rule of the human evaluation. Is it here to stay?
I mean, look, we did this at Aardvark 15 years ago. I worked at a company that was acquired by Google. It was the same thing, except instead of generating text, we would ask it an arbitrary question, and it would try to find someone to answer it. And you always had what we would call, there was a name for it, Wizard of Oz testing. So if you remember the movie in The Wizard of Oz, there was a magician behind the curtain pulling the ropes. And so we always had the system when you would ask a question, it would look like the ML system found someone to route it. What it would do is it would route to a tech team, an ops team. The ops team would read the question. The ops team would look at the answers the machine learning system was provided, and then it would ensure that the machine learning system didn't give something crazy. And so when you're implementing a system like that in a big company, I have a whole talk on this. the idea is that there's a point where you have humans in the loop, and the humans are going through the list of suggested responses and finding the response. Kind of like, remember in Terminator, when he has to go, he's like, oh, here are all the answers I give, and then at some point there's a crossover. So when the system gets good enough, you have enough user feedback, instead of having the operator select the best response, they simply look at the responses the machine is giving and intervene if something looks crazy. Now the problem is that's expensive, right? You have to have a lot of humans, and they're going to be monitoring this thing all the time. But that's how we ran it. And I think that people may be surprised that a lot of search engines, like big search engines, do that too, because we were run by ex-Googlers, and they have people who are evaluating things. There are cases where there are humans in the loop, because you want, in particular, for example, whenever a user starts using a system like this, you want to make sure that your bounce rates are low. In other words, you don't want to bring new users and have them leave, right? So we would route to it. We would always take the machine learning system, and if it was a new user, we'd route to a human to make sure they got a good response. Then after they're in the system for a while, then you kind of let the machine run everything. And then if their engagement starts going down, then you route them back to the human, right? So we play these games because human interaction is very expensive. We had the same problem. I worked on customer support at eBay, and it was the same thing. You had a machine learning system classifying emails, and every once in a while, like customer support, it would get in. We had this joke. We go, when in doubt, route. And what would happen is a bad email would come in and would just get routed to every single tech support person in the company until it could find someone who could answer it. And this was costing a fortune, right? So you have to be very careful when you have human in the loop, because in order to manage the cost, because it will just like your AWS costs, it will skyrocket.
And I think that's one of the main concerns when you have a human in the loop is a lot of companies looking not only in the cost, but there is a lot of concern in the bias as well. So not everybody like in the loop having the same type of expertise. Same person might have totally different perspective in different time of the day, depending, especially
yes,
when
absolutely. Or it's when you start trying to gauge what's going on. And I wish I could say, look, there's this magical metric and you use it and it will make everything work. There's F1 score. Even that's not really great in a lot of cases, right? If you're doing like search, you have so many negative examples. The F1 score doesn't help you. What you care about, how many clicks did you get? How many purchases did you get? What's your bounce rate? What is the, how many dead queries do you have? Right? People start querying, they just stop. How many things go into the cart but never get purchased? There are many of these things are very customer specific. They're specific to how your users are engaging with the system, and you have to measure them. And the other thing that is so awful is that you might think that you can design a machine learning algorithm and that will somehow predict performance. Like, oh, I have complexity, or I have, some rogue metric or something like that, or your truthfulness. There's a great paper that came out of Meta a few weeks ago that where they looked at 635 experiments and they compared it to the old machine learning models. Not a single machine learning model matched the closest model was 300% off, then 1,000% off, then everything else was just nonsense. Like, unless you design experiments very, very carefully, it's very hard to go back and understand, does the model actually predict what's actually happening in the production environment? And I think when it comes to evaluations, you have to really think about, what are the, if you're doing search, like in RAG with search, typical things would be bounce rates, dead queries, how much of the tail are you actually sampling? If you're doing e-commerce, how many things end up in the cart and never go away? These are things, and that stuff can be, if you're at scale, that can be very hard to measure, especially things over time, because typically logging is done on a daily basis. and you might be able to get a few days back of log. You might be able to get a week back of the log if you're lucky. You think you're going to get a month back of the log? You know, you're going to do joins. It's very, very hard. I worked in system with Walmart. People would put stuff in their cart, and then at the end of the month, they would buy it. But we couldn't get data joined on the logs to see back when when the object was put into the cart, because it was just the joins were too long, to do the joins every day the way the indexes were built on the tables.
And
So with LL,
yes, it's very important just for here to understand that human has a limitation, and everybody nowadays is trying to shortcut it by replacing human with the GPT, which is using LLM as a judge or evaluator. So what is your thought in that? Like, we know that human has a limitation, but are they still the gold standard, or can LLM replace them at any given moment?
you might be able to ask, here's an email from customer support, and here's the response. And was it a good response or a bad response? And you might be able to get an LLM to sort of read something like that and give you a good or bad response on the user interaction. Because normally the only thing you do is ask, how would you judge that normally? Like, did the user like the interaction? You could count the length of the interaction. How long did they engage? And you do like basic sentiment analysis on the engagement. So, and now the LLM can go in and kind of read the interaction and try to figure out, was the sentiment good or bad? That kind of stuff is probably very doable and would probably extend things that have already been in production for a very long period of time, but not particularly accurate. The problem with any kind of custom thing is that the LLMs both hallucinate and they overfit.
Absolutely.
Right? They do both, right?
Yes.
And you don't know. How do you know if it's overfitting? Who knows? People are training these LLMs. They're trying to do RAG, or they're trying to do fine tuning with some tiny little lower space and 10 examples. How do you know you don't overfit? Right? It's not like in the old days you have 100,000 examples. So it's very difficult to get, and I don't think people are really ready for that yet. They don't really know what to do, because right now most companies are focused on just getting things operational. Like, and are they doing fine tuning? That's hard. That's hard. Maybe they use somebody else's platform. It takes a lot of GPUs. You got to set it all up. How do you monitor also in terms of evaluation? So a lot of people are still doing prompt engineering, and, you're trying to evaluate, you're using one LLM to evaluate the response of another LLM.
And I think that would be the main topic for 2024 is monitoring, which is post evaluation. It's very important because your product right now in production, your user is giving you a lot of feedbacks, something that probably you never expected. So, and this is I think a good segue to look into what's coming. Like,
I would say I think right now what's coming is that people have no idea what these models can do. And there's this huge question. Are they really able to do the things that the evaluations claim? Do they really have the cognitive performance of a 9-year-old? Do they really produce good code? Right? Do and you have this, people are now beginning to see, unless you have very sandboxed, lockdown test sets that you cannot get into the training data, that you don't know whether the model is actually, the data has been contaminated or not. And that's a huge problem. Now, in a corporate environment, it's probably not so bad because, your data is probably, hopefully not out there on the internet. But I think people are going to try to figure out what the LLMs can really do. What capacity do they really have? There's a lot of anecdotal ideas about, if I do this prompt, if I give it a tip, it'll do better, or if I threaten the LLM or say my job's on the line, it does better. How much of that is really statistically valid, or is it just sort of, folklore at this point? How much of it has really been evaluated, or is the LLM just non-deterministic and you're just picking up this sort of non-deterministic behavior? I think that when it comes internally, the idea of overfitting to me is just, that's sort of why I invented Weight Watcher, to try to solve these problems. But I think another problem people forget is that in any production environment, so talk about monitoring. two things. One, you never know who's actually using the models. Like, and remember, I'm in a
Exactly.
company. I'm going to give out 10,000 tokens, and the people are going to start using the model. How do you then go back and figure out what group spent the most tokens? Like, I mean, I guess you could look at the usage, but you really don't know data. It's, you don't really know at an operational level. You have to just kind of go back and look at the billing and figure out, okay, can you tell, you don't know who used what token, how are you billing for it, how are you tracking the usage? But then there's another problem that I've always seen in every production environment. Things fail all the time. Databases, indexes get screwed up, data pipelines fail. Somebody makes a change in the website and it breaks some of the data ingestion and it goes all the way down and comes back. And that's going to somehow end up in the model. How are you going to know that? It'll be, you can see it in a traditional machine learning algorithm because you see the performance go up and then you see it goes down. How would you detect that if you're fine tuning your own LLM or you're doing RAG and all of a sudden the stuff you're putting into the prompt is just pure nonsense? How would you
This
know that?
this is a really good point, and I want you to talk more about for it, because I've noticed, like many of my clients, that we come and we do the customization for them or fine tunings, but there is a lot of things that goes unexpected. So in this case, are you of more of the conservative type of guy where you prefer to have everything refined to perfectionism? Then
I
you
I
deploy it, or you just deploy it and you see?
I would just like things to run for more than 6 weeks.
Got
I
it.
have worked on clients. I gave Walmart a project. Should have made them $1 million a day. I know this because it's been running at eBay for 10 years. I gave them this algorithm. It falls down all the time. Why? The organization's just too big. There are too many
Mm.
things changing. The database changes, this changes, that. Things fail all the time. And what I find is that whenever you're dealing with data,
Mhm.
unless you can go all the way back to the source and track exactly how the data is entered and how it's and what the joins are and who's accessing what, unless you have some visibility into that process, you can't trust the data. It just breaks. And what I have found is that I have spent an enormous amount of my time with my clients, not trying to make perfect code, but doing triage in production. Models fail in production constantly, and I'm constantly in there triaging the models. And I can't imagine with this kind of stuff, like, how are you going to triage it if you don't have any way of evaluating? Like, forget it, like, just basic things. Is this correct, or is it just like huge red flashing light? How do you log it? How do you log errors? Stuff like that. So those are the things that when I think about production is that's what I've always seen in companies, that these kinds of problems occur and there's no way to go in and fix it. And so you have to think, how would I go into the environment and how do I detect the problem early? Because you want to, if a problem arises in production, you want to get to it before you have to go in and triage the live production system. Because that's a nightmare. You're in there live and you're mucking around with it. Um, those are the kind of things, how do you do testing, right? And a lot of the other thing is a lot of enterprise environments have very well established best practices for software engineering. And now you're putting brand new green technology into that environment. How are you going to integrate that into the processes that they have? Are you gonna, how are you gonna, like, are they using Git flow? Are they doing automated builds? Where is the logging going? How do you, if something fails, how do you get into the production system? How do if you need to change code in production, how do you do can you pull it live, or do you have to go through the whole process again? Latency issues. How do you deal with latency? These things are not fast. So those are the kind of things that I see all the time in production environments. And when it comes to evaluating it, those are the kind of things that I would be more concerned about, is trying to just figure out where things break and detecting. I mean, I spent an enormous amount of time just trying to detect failures so we can, so we can go in and make sure something just doesn't completely fail.
You mentioned Weight Watcher, and I would love to maybe like just shed some light on the specificity of it, like, and how it fit into the evaluation
Well,
in general,
let
and
me,
maybe LLM evaluation.
sure, sure. So look, I started working on the theory of Weight Watcher almost 10, 8 years ago when I was getting into this stuff. And I realized that I need to find a way to know if my models are converging. Because I'm just, you're tweaking hyperparameters here and there. You have no idea. Imagine now, people just do things blind. They hope it works. Weight Watcher, what it allows you to do, it allows you to, it gives you layer by layer diagnostics of a model without needing access to any data. So if I'm in a production environment and somebody says to me, here's the model, I want you to put this in production for me, right? Every environment, a big environment I've been in, so, there's somebody else putting things in production and managing it, some DevOps team or something like that, LLM ops. What it can do is, let's say you fine-tuned your own model. It can evaluate the fine-tuning at layer by layer, and it can detect potential problems that occur. Did you overfit the layer? Was there enough data? Did the data pipeline, so here's a good example of what it might find. Did the data pipeline suddenly change and now half the data is missing and you didn't know? That's the kind of stuff I've seen that happen in production, where data just goes away. So it can detect problems like this without needing access to training or test data. So by doing this, it's much easier from a compliance perspective, because you're not looking at user data, you're just looking at user models. I mean, there's always an issue with compliance, but you're just looking at the model. You're not looking at user data. And it can tell you things like, here are 10 different models that our team has produced. We can only A/B test 3 of them. Maybe only test 1 of them. Which one should be A/B test? It can tell you, A/B test this one first. It's most likely to give better performance. And it doesn't require, and you can do it at the fine tuning level. So if you give me 3 different models that you fine tuned, I can tell you which model I expect to perform better just by looking at the weights. I don't have to do an evaluation. I don't have to do rogue. I can even tell you, based on the base, if you have used different base models, which ones are more likely to hallucinate. And so it's an early warning system for evaluations. It can't give you like, how well are you going to do on this out of sample coding example, right? Like, to get into that level of granularity, you have to go and really run very detailed evaluations and hope that represents what you want. But from a production perspective, it can give you, it's an early warning system to tell you something's totally broken. And we're also working on a technology where we can actually go into the data set and tell you, if you overfit the data, what layers are overfit and where in the data set did you overfit? Like, what part of the data set is screwed up? And then you go and fix that part of the data set. So that's the kind of stuff we're working on. And I built it because, in my experience, the problems that arise in production are not these sort of micro level things. It's more something just breaks and nobody knows why, and it stays broken for 2 months and nobody can fix it.
It is absolutely a major issue when it comes to the LLM evaluation. And I think from what I've seen, like, there is, prior to you even doing the fine tuning and deploying your model and do the evaluation aftermath, there is this pre-evaluation, which is, you wanted to decide which which model that could serve your use case. So it seems to me that Weight Watcher, it served that purpose very well. But
that's exactly it.
I wanted to understand 2 things, like giving the amount of parameter that those LLM has, and if you wanted to scan all of those weights, is it feasible for large language models, or how you approach it?
That's not hard. It's not hard, because I'm not running a GPU on that. It takes a little time. The way I have a commercial version I'm working on. The way it works, it spools up array cluster, but it doesn't need a GPU. It can do it on the CPU. So you can do like a large memory CPU machine. And basically the hard part is getting the weights to the system. So there's an open source version you can run in production, Or if you want to, the one I'm working on, you would take the weights on an S3 bucket and you would either move the weights from one S3 bucket to another, or we try to configure it so it would point to your S3 bucket to where the model is. And it just reads the model. And the idea is what you want to do is you want to save the model. Ideally, you save it in like safe tensors format so that you can read incrementally. You don't need a huge amount of memory. Otherwise, you have to load the whole thing into memory. But because it can go layer by layer, in principle, it can just go layer by layer off the disk. Or it can stream and do it in parallel. So there is a bit of a hit to analyze the model. But if you're fine-tuning models, technically all you really need are the updates. Right? And the updates, I mean, if you're doing like LoRa, with like even a modestly large rank, like 128 rank matrix, which is huge for LoRa, right? Most people do like 8. But if you like, but if you have like a 60, because Weight Watcher needs to have a fairly large, but if you're doing like a fairly mid-range LoRa model, those aren't that big, because you don't need the whole thing, you just need the update.
Yeah, for LoRa, I think I've seen something like 1% or maybe 1.5% of weight updating. So
and Weight Watcher is sort of in the mid-range. It can't tell you that much about tiny little LoRa updates because there's almost nothing there. Right. Mm-hmm. But if you have if you're doing like sort of half the model or you're doing full fine tuning, you just have to get the weights into the system. But compare that to evaluating all the data, which is much larger, usually much, much larger. Like the data sets are usually much larger than the weights. And if you have to, if you're trying to, but that it's a good question. It's probably the one challenge we have is getting the weights into the system. And it's sort of something we're working on now is in working with customers. Is it better to transfer weights from one S3 bucket to another? Would it be better to have an on-prem system? Like that kind of stuff we got to figure out because it's all very, very new.
That is absolutely great.
What I've seen though, I haven't seen I think it's going to be about 6 months before people are really fine-tuning all the time. Like right now, I think sort of the people are getting into it, but I don't think it's like mainstream yet. I think what I've seen, a lot of people are still trying to just survive on prompt tuning and RAG.
I think it's going to be very soon to realize like the limitation of RAG because you have a lot of latency. You could have a lot of accuracy in the RAG system, but with adding a lot of prompt layers into it, you already, as a byproduct, you're adding a lot of latency. So that's one major issue that people has. And also the cost, like the more tokens that you put into your own prompting, the more money that you're going to be obviously paying. And you're consuming already a lot of the contextual window already, and instead of having it for your own retrieval system. So I'm pretty sure like within maybe 2, 3, 4, 5 months, we're going to see a lot of people going into the fine tunings. Especially right now, you can fine tune with relatively like small amount of money. You can fine tune something like I would say 50,000, maybe 100,000 data point in QA.
Oh yeah, that's a huge amount. Yeah,
it's a huge amount.
Fine tuning with 10.
Exactly, and
no,
you don't
pay,
right. You don't pay much. Like you pay like maybe $500 to $1,000. So giving that,
I think it's a great point. Look, I've worked in enterprise search. We have latency requirements of under 200 milliseconds. Okay. I don't know what you're doing with prompting, but that's either you're not going to hit it or it's going to cost you a fortune.
Absolutely
right? Just
not.
trying to do that.
Yeah. And also there is a lot of people using those API-based type of LLM, like OpenAI and so on and so forth. That's like you just adding an extra layer of latency as well.
Boy, and remember that OpenAI almost went out of business. How many heart attacks do you have on that weekend, right? I mean, look, I worked years ago with eHow, and eHow, people probably don't remember this, 2010, we were the first $1 billion IPO since Google. And one day Google just turned us off. Like, we don't want you anymore in our search index. Whenever you're using somebody else's platform, there's real platform risk. And if you get big, like we did, eHow was at one point, we were one of the top 10 or 15 websites in the world. When you get to that size, people might decide, we want your business. And they just turn you off. And that's what happened to us. So I think there's significant platform, especially now you're dealing with Microsoft, so there are significant platform risks as well. And so I can see people wanting to move to do fine tuning. And what I see with the fine tuning is nobody really knows how to measure hallucinations. It's very hard. Um, how do you know if you're overfitting, right? And so those two things are, I think, intertwined. And I think that that's why we try to develop a theory to do this, because otherwise everything is just, it's just custom, right? You just have to, there's very little you can do other than to try to integrate it into whatever workflow and business processes you have on how your customers use the product.
So going into 2024, what do you think of the future will be more into the commercialized AI or more into the open source? As Meta is pushing for a lot of open source, and so how do you read the trend in this case?
I think it's going to depend on how easy it becomes to set up and integrate these platforms. I mean, the thing about prompt tuning, even though it's getting, it is where it is, right? It's not like, are there going to be huge advances in prompt tuning? Maybe people understand better what these models can do. I think that eventually people want to own their own models. Big companies want to own their own models. You don't want to be tied into somebody else. And having open source gives you the opportunity to own everything you're doing. Now, the challenge of that is that you have to then do it, which is hard. Prompt tuning is very easy to integrate. It's much easier than trying to collect data sets and label them and make sure you're fine tuning and manage all that. And I think we're going to see is sort of right now there are sort of prompt fine tuning platforms arising, pay as you go platforms. I think there's always going to be this challenge, though, because in most organizations, unless you have a mandate from above to really turn the organization into an AI-based organization, what you find is that you have managers who are really sort of trying to survive quarter to quarter. And you can get a much faster win with prompt tuning or with RAG than you can doing fine tuning, just because of the amount of effort it's going to take. And so I think that has to get simpler and easier for people to do. But I think long term, when you start wanting to actually see performance, it's the only way I think you can really guarantee that you're going to get the kind of performance you need. You just, how are you going to get rid of all these problems that arise? You have no control over what's going on with the prompts. I mean, it could do anything.
That is absolutely a great point. Thank you so much, Charles. I think this is very valuable for everybody. I really appreciate your time, and then maybe we see you soon.